So next we're going to be hearing from the Department of Defense, and not just anybody from the Department of Defense. This gentleman is the Chief Software Officer for the Air Force and co-lead for the DoD Enterprise DevSecOps initiative. Nicolas Chaillan has founded over 12 companies. You've launched 180-some products to production, selling them to various entities and agencies around the world. And so, Nicolas, I'd love to welcome you to the stage now, and thanks for being here. Thank you very much.
I did. Oh, here we go. Cool. Good morning. Well, you'll see we have a big talent problem in the federal government because we have to bring a French guy to the Department of Defense to come fix DevSecOps. But you'll see this is pretty exciting because we are collaborating across all DoD services. So we have the Air Force, the Navy, the Army, the Fourth Estate, working with us to move to DevSecOps, removing impediments and really trying to understand what is the difference between DevOps and DevSecOps. And maybe we won't agree on that, but that's okay. I'll tell you what I think is the difference. And I will show you also kind of the maturity level of where we're trying to go to be able to scale DevSecOps across the Department of Defense. It's a joint team with DoD CIO, ANS, OSD, and the services. It's being led by my team now at the Chief Software Officer office, which is kind of funny because when I joined the Department of Defense, I told them I want to do everything like the commercial side. And the first thing they did, of course, is come up with a title that does not exist on the commercial side, right? Chief Software Officer, which is interesting. We kind of see it as a CIO on the commercial side, which is really delivering enterprise services and bringing cloud and tech stack across the Air Force, but also can be used by the other DoD services. So you'll see, and of course I don't have a screen, so I don't remember my slides, but you'll see what we're trying to bring at scale. Just so I know, who is using or has heard at least of Kubernetes? Kubernetes, okay. Service mesh, you know what a service mesh is? Okay. Istio, great. What about infrastructure as code? Cool, awesome. Maybe some of you don't raise your hand because you don't understand what I'm saying. That's another. So we'll see. But anyway, so why do we care? Of course, well, software is part of every part of the DoD's mission. You may not realize, but we're doing DevSecOps today in the Department of Defense, including for weapon systems. So when people say, I can't do it in my agency or I can't do it in my company, if we can do it for weapon systems, actual weapon systems, you can do it for pretty much anything. And so this is happening today. We're a little bit behind when it comes to China and Russia. So we want to catch up, right? Very important to make sure both for AI, machine learning, and really DevSecOps is kind of the enabler to really be able to scale AI, machine learning, big data, right? And enable teams to move faster and do rapid prototyping and be able to get rapid feedback from the actual end user, right? And so when you look at that joint team, what we're bringing on the technical side, because I'm a tech guy, so I like to talk about tech, I'm sorry, but you'll see that we are using containers, the entire DevSecOps stack. We don't have virtual machines running except to run Kubernetes. Everything we do is based on Kubernetes. We don't want to get locked into Pivotal, Red Hat, no offense Red Hat people. We don't want to be locked into Red Hat, so we want to make sure we have options, and so we're mandating a CNCF compliance with Kubernetes and OCI compliant containers. Everything we run is containerized. We don't have Jenkins, we don't have GitLab, we don't have GitHub running as a VM. It's a container, self-healing, self-updating, and we centrally accredit and update containers DoD-wide. That gives us the ability to centrally update all these products, which is pretty cool. We're going to be supporting 172 containers. You can think about databases, API gateway, service mesh, build tools, CI/CD tools, cyber products, and we cover every aspect of cyber from the static dynamic analysis side of the house to container security with Twistlock, Aqua, Onco, and other products. So you'll see that we have a very broad set of options because there's not a one-size-fits-all when it comes to DevSecOps. So the goal for us is to be able to bring options. We have turnkey CI/CD options with complete automation, infrastructure as code. They can deploy it on any cloud or any on-premise environment with the push of a button. or they can also set up their own stack and just use the containers, simply pick the one they want to use, and we accredit containers up to TSSCI SAT, right? And so based on the findings of the container, we accredit the container, and it can be reused DoD-wide with complete reciprocity across the department. So no authorizing official can come and refuse to use the containers. That gives us the ability to deploy this software anywhere, like Lego blocks, right? And so we have this central repo, which, by the way, is publicly accessible. You can shoot me an email, I'll send you the link. It's still not fully public, but it's free and it's open. It's available on a public domain, so it's not a .mil domain. So you can go and see the containers, you can use the containers. We even have a universal base image that Red Hat created to be able to have that stigged base OS. So we have that base OS container that you can use to build your different layers on top, right? So if you have a Java container, use my Java, OpenJDK hardened Java, which uses the base OS that we already hardened, right? So you ingest for free all this hardening without having to do it yourself. And so if you have a Java app, just use a Java container, right? And same thing for vendors, right? So we have vendors that come and say, teams like CloudBees, Jenkins want to distribute their cots into the repo. They can simply use our base OS stigged and then simply inherit that and give us the containers. And we rebuild, we rescan, we sign it, and then we push it to the unclassed side of the house, and then it's pushed also to the secret and TS environments. So we can use that on any environment. What's also interesting is we kind of created the concept of this continuous layered ATO. It's pretty new and unique. The way we accredit the stack now, we have layers, and so you could swap your infrastructure layer. So let's say you're moving from Amazon GovCloud to Azure Government or on-premise. We accredit these layers separately, of course. Some is using FedRAMP, some is using on-premise ATOs. And you can swap layers without having to redo your full ATO for your application, right? So you can move that application to different environments. You can swap from OpenShift to something else, no offense, or PKS back to OpenShift, right? And now you don't have to redo that ATO process. And it's a continuous ATO, which means you can push software to production multiple times a day. The key aspect is the ability for us to track, of course, the continuous monitoring side of the house. So this is the difference for us between DevOps and DevSecOps. We use sidecar containers to be able to inject cyber products into our clusters by default. So there's no development team that shows up and has to remember to launch that cyber agent that you're trying to use. So we use the concept of sidecar. A sidecar container, for people that don't know, is just a container that's running alongside another container. And the big difference is it's not actually inside the container, right? It's alongside. So if you have an agent in the VM and the VM is compromised, the first thing the bad actor is going to do is tamper with the logs, and then your agent is worthless at that point, right? With a sidecar, because it can still see what's going on inside, they would have to hack the entire cluster to be able to tamper with that. In the meantime, we have behavior, not just CVE, right? Behavior detection with product like Twistlock, to be able to detect what's going on in runtime, but we also do zero trust model across the entire stack. So we use Istio to be able to inject a zero trust at the container level. So two containers cannot talk to each other if they're not whitelisted, right? So see those slides. So of course the value for the teams, you get it. They can instantiate DevSecOps in minutes on any environment without having to reinvent the wheel and build a factory. We call it a software factory. I don't love the name, but that's what it is. CI/CD, whatever you want to call it, DevSecOps pipeline, CI/CD. Of course, the value as well is a continuous ATO. They can inherit that continuous ATO DoD-wide, so they don't have to redo that. And the factory itself is on the continuous ATO, which means software built on top of the factory inherits that ATO. And assuming they're passing the scans and the tests, so we mandate minimum test coverage, meaning X% of your code is tested automatically with unit tests, integration tests, end-to-end testing. That's how you get to that continuous ATO. So any software coming out of the factory, passing the mandate of testing, passing the scans, can go straight to production. All of this, by the way, we funded this 10 months ago. We have 34 Pathfinders now. Business systems, weapon systems, cyber offense defense across all the DoD services. So it's pretty cool to see in 10 months, how many people are working together across the fourth estate, Transcom, SOCOM, and DoD-wide. It's pretty exciting stuff. The sidecar stack, what's pretty exciting is the ability for us to inject the sidecar and have that baked-in security in place. That's the SEC side of DevSecOps. Okay, if you're not doing a proper job in your continuous monitoring side of the house, you can't do DevSecOps. Okay, it's not about doing static analysis in your pipeline and doing a few scans once in a while or every day or multiple times a day. It's the continuous side of the house, and the continuous side of the house has to be automated. No human in the loop. No one can forget to deploy an agent, right? And forget that. By having that automation to inject the cycle stack and the service mesh, that's where we really bring the value. So as you can see, the move we're making is moving from waterfall to agile, which by the way is 19 years old. Just so we realize how far behind. NDA 18 was mandating the use of agile. Great. Now you're going to see NDA 20 from Congress mandating some DevSecOps stuff finally. Then the move from monolithic application, right, cutting this massive application into microservices. And yes, we're using microservices for weapon systems. You wouldn't believe it, but it's happening. Physical servers moving to VMs to containers, right? And we also support function as a service. So people that know about Lambda, we actually use Knative, which is open source. We don't get locked into Amazon, right? We can't be locked into anybody. So think always about abstraction, right? We use Kubernetes to be able to abstract. If I need storage, I need compute, right? I don't talk to Amazon APIs or Azure APIs. I talk to Kubernetes, and Kubernetes will do that for me, right? Same concept for Knative, for function as a service. We abstract it so we don't get locked into Amazon or Azure or anybody else. Hosted to the cloud. Cloud doesn't always mean you're on the public cloud for us, right? We have classified clouds. We also have on-premise environments where we have this 20-inch by 20-inch box that has 150 CPUs, 50 terabyte of storage, and you can actually deploy that on-prem. But the key is not just, hey, I have a virtualization stack, right? I have a full API stack, so Kubernetes knows how to get my load balancer, my IPs, my software-defined networking. If you don't have that, you don't have a cloud, right? The cloud is not just I have a bunch of VMs running on a machine, right? So we have that on-prem, go up to 130 degrees Fahrenheit, can be deployed anywhere, and it's a kind of tiny rackable box, and you can also just carry it. That's an example of a pipeline. As you can see, the complexity is always the number of tools. That's just a subset of the number of tools we have in the stack, right? It's just one example. All of these tools are containerized, running on top of Kubernetes, and the key for us is to really make sure we let people pick, right? So by letting them understand what to use, the scanning side of the house is here with the traditional scanning products that you know, the Fortify, the SonarQube, but also the container scanning tools as well. But then the key, of course, is your orchestration, the Jenkins, the GitLab, and then, of course, the ability to then deploy. And I want to insist that you should not be using anything but Helm or Kubernetes Operator on top of Kubernetes. You should not use Puppet, Ansible, Salt, Chef for anything else but setting up your cluster, right? So we use Ansible to set up the cluster. Anything above the cluster is set up with Helm or Kubernetes Operators, because now you abstracted. You don't want to get locked in as well, because everything that's code, right, can be then locked in to whatever tool you're using to create the code, right? So the big push as well for us is a mesh. Service mesh is managing your east and west traffic, right? You're moving to microservices. You could have people using different programming languages, different teams, ideally decoupled with a 2-pizza rule. Who knows the 2-pizza rule? Who has heard of the 2-pizza rule? Okay, so the 2-pizza rule is to size your team. You have to be able to feed it with 2 pizzas. If you have me on the team, it's going to be not many people because I eat a lot of food, but it's really between 7 to 12 people. Okay, but the fact is that's kind of the way you size your team, and using the mesh will enable you to decouple all authentication, load balancing, routing, east and west traffic, encryption, right? So for example, if I have two teams building a container that talk to each other, I don't care if they use encryption. Why? Because my service mesh injects a mutual TLS tunnel by default. It's going to get encryption for free. It's going to hijack the IP table, and even if they don't use encryption, it's going to encrypt it. What Istio is also going to do is create the strong identities with keys for each of my containers. So automatically they're going to get keys, and they're going to have strong identities, and I can do the whitelisting, right? Because by default, again, zero trust model, denial by default. So we whitelist what container can talk to what container, right? So that's the beauty with the mesh. You're not doing it in a specific programming language. If you have teams coding in Python, Go, Java, C, C++, whatever else, you don't want to have different libraries to maintain to be able to do authentication and all this stuff. We're talking about load balancing and all that. So to replace that challenge, we use a mesh, which is a sidecar container. Istio use Envoy, which is a proxy. And Envoy is going to do that job for you to inject that mutual TLS tunneling, load balancing, A/B testing, canary release, and all the good stuff that's mentioned on that slide. Load balancing, layer 7. And that's kind of bring that value of abstraction, so you don't have to be dependent of a library or something specific to your programming language. In terms of the way we architected the stack, each team can spin up their own cluster, so we don't have a centralized hosting just yet. So the way we ended up doing it is we will have a cloud on Azure and Amazon and JEDI when JEDI is going to be available for DoD, where we're going to have impact level 2, 4, 5, 6 for us, so that's unclass, PII, national security up to secret. And we can spin up a cluster, there with a push of a button with automation. In the meantime, each team can spin up their own stack wherever they want. It could be on-premise, it could be on the cloud. And the gray box, that's their environment. All they need is Kubernetes. They can abstract it. They can go to our friends at Red Hat. They can go to Pivotal. They can go to VMware. They can go to Mesosphere and get that cluster spin up. On top of it, you're going to have your CI/CD pipeline that's completely containerized using my containers. So my repo has a bunch of hardened DoD containers. Just take that, spin up your CI/CD pipeline. The sidecar stack is injected to the cluster, and that's also a bunch of containers coming from the same repo. My repo is on the top right corner. That's pulled locally inside an environment automatically. That way you have it local. You can go offline. You can be on a Navy ship. We have a cluster right now on a Navy ship offline that can do compile to combat in 24 hours, right? So you can actually push code in 24 hours on the ship offline, right? And so we can cut that connection to be able to go fully offline. All the logs, all the telemetry is centralized. We use EFK to push to Elasticsearch, and then that can be pulled by DISA, Cybercommand, and the DoD services, CIOs, to be able to see that telemetry. On top of it, you have your app running, which inherits all these controls, all this baked-in security, which, by the way, automates a lot of the NIST's RMF process, right? You're down to 10% of the controls at that layer if you have a mesh, right? If you don't have a mesh, it's a different story. But for example, because the mesh gives us encryption in transit for free, you don't have to worry about it at the app level, right? So you inherit that. Keys, everything is code, your source code, every piece of the networking, whitelisting is YAML or code in your repo that you can change and update, right? That's a critical piece for us to be able to spin up the application on any environment with no drift, complete automation. So just some slides to show you kind of what containers we're covering inside the repo. We're going to have 172 containers within 6 months. 23 databases, including big data, NoSQL, AI, time graph databases. I saw a couple of people with graph t-shirts today, so Neo4j is right there. 16 programming languages, artifact repo, source code repo. In terms of the base OS, right now we're not going to do all this. Right now we just have UBI because that gives the ability to have support for us if we have a RHEL license. But if we don't, you can still distribute the same container without breaching the terms and conditions of our friends at Red Hat. So that's what we use. We use Knative, not kubeless, for serverless, for function as a service. Web servers, logs, proxies, message buses. We have Kafka. We have all the good stuff. Security tools, we cover every aspect from static dynamic analysis, container security, STIG, automation with OpenSCAP, bit of material. We have Black Duck, Nexus Lifecycle. Then we have products to do NIST automation to create tickets in Jira if you have gaps in your NIST compliance automatically. So products like SD Elements, configuration management tools, test coverage, all the test suites. Very important that you give the freedom for your teams to pick the test team, the test suite they want to use. So we have a lot of options for tests, and that includes UI testing, that includes traditional unit testing, end-to-end testing. Even more important when you move to microservices, you want to be able to demonstrate. There's a reason why Google is doing 150 million tests on their software a day, is to make sure that when they add a piece of code, it's not going to break anything, right? So that regression test is critical. Documentation tools, performance tools, secrets. So don't store your keys. For my good friend at Red Hat, don't store your keys in the repo. Put it into a vault. It's rocket science. They understand why I'm saying that, by the way. Planning, collaboration tools, chats, monitoring tools, and of course, different clouds that people can use. Last thing, sorry, I only have 25 minutes for something that usually takes 45 minutes. And then you add my French accent, that's like even harder. But anyway, the strangler pattern, for people that want to move from legacy to DevSecOps, the only way to do this, there's no two ways, by the way. If you're doing it a different way, stop right now. You're wasting taxpayer money. Strangler pattern. Strangler pattern will take the legacy and strangle it. We're not killing anybody. We're just killing the legacy. And the way we do it is we put a service mesh on top. Initially, it just redirects to the legacy. You take a look at your legacy. Because you've got great training, I'm sure, you can now learn about domain-driven design, DDD, which will allow you to cut into domains to understand your microservices and your bonded contacts and how you cut a monolithic application. If you don't, we have a great training at DAU that we spin up to be able to educate people on how to cut a monolithic application into microservices using domain-driven design. And so that's how you're going to cut it. Let's use a simple example, e-commerce application. You have products, payment, billing, search, users, whatever domains, right? The key of the strangler pattern is to prioritize the features, the new features, and the refactoring based on end users' requests. So you don't just rewrite for 3 years. You actually prioritize by first looking at what the end user wants in terms of new features. So let's say your end user, you have this great e-commerce app, he wants to get a recommendation to buy more products, which usually is not going to be your end user asking for that, but that's okay. Recommendation, 5 products, you think about it, it's inside your product domain, right? Because you're going to have to change the product detail page. So the product detail page is just a microservice. You use the 2 pizza rule, so you can build this in 2 to 4 weeks. 2 weeks, you get this product detail page rebuilt. Maybe a same team or a different team build a recommendation microservice, right? Now you have 2 microservices, 6 weeks, because you use a beautiful CI/CD pipeline with a continuous ATO. You can push that to production in real time. Legacy is still there. Now you have 2 microservices. The service mesh will now point to those 2 microservices until you have more, right? And the rest still points to legacy. You keep doing this by prioritizing based on features or security. And by the way, when you put the legacy to the side, put it to the side and don't touch it. Only for patching. Don't start cheating the system. If you start touching the legacy, you're just going to be compounding the problem. Only patch updates, that's it. And then slowly but surely you're going to rebuild. It's going to take maybe a little bit more time. But the key here is you're delivering new capabilities while refactoring the code, right? And that way you can demonstrate to the end user and to Congress that you're bringing value in real time, not after 3 years, and not just rewriting a piece of software for 3 years. Any questions? I don't know if there is a mic, because I probably won't hear you. Oh, here we go. Yep. That's a great question. So what are the dependencies? So how do you deal with dependencies across containers?
Repeat the question.
Yes, okay. That's the question that I was trying to. Sorry. How do you deal with dependencies across containers, and how do you make sure that they get updated, and if there's a patch or an issue in one of the dependencies, the rest of the containers get updated? So it's that's the core foundation of the container factory that we built. In fact, my MVP, because that's what you should do, right, an MVP, was a factory, which is a CI/CD pipeline, that automates the pull from internet to get the last updates. We rebuild the container offline, we scan it, we sign it, and then we put it into the repo. That process is also automating the detection of changes into the dependencies, and if there are dependencies of other containers, it then rebuild the other images as well. So it's a whole factory. It's not easy, but we have it on the repo. The whole code is open source. Everything I do is open source, by the way, so you can go and, yes, DoD is doing open source. You can go on the repo and see the code on how we automated that process of pulling these dependencies, checking that, and then updating it. It's still evolving because it's something we launched 2 months ago, but it's pretty strong. Questions?
You didn't mention operators, or maybe I didn't see it on one of your slides that went by too fast. Is that just an oversight, or is it something that you're going to work in?
Operators, you said?
Operators.
Okay.
Yeah, so Helm and operators is the only way. And when I say operator, maybe you hear a different word, but that's what I'm trying to say. Helm and operators are the two preferred way for us to ship software on top of Kubernetes. We use operators and we use Helm. We also have a custom and mission controller, and we're working with John at Red Hat. Where is John? Say hi to John over there. He's writing, he's great, right? He's writing a bunch of open policy using OPA. Who has heard of OPA? OPA? Well, go Google OPA. And then go talk to John, because OPA is game-changing to create policies so we can define access control and a lot of different things and rules across not just Kubernetes. It works for SSH, it works for any product. That's why I love OPA. It's open source, so we're building policies on that as well to be able to enforce settings and things like that. Sorry.
Cool.
No more time for questions,
No.
right? Sorry.
Thank
Thank
you.
you.